Commercial refrigeration condensers. This is a common tabletop looking one. Now they do make Coleman does make a residential that looks like this with only one fan in it, but this is just another condensing unit. Tube and fin condensers, which are the standard we see in the industry. Microchanneling condensers. Some of these are getting very popular, with Trane and Lennox having a lot of microchannel coils out there. Head pressure control. Method of cooling head pressure under varying conditions. So for example, I'll tell you a little story. I went to a gas station, and it has a lot of frozen food like ice cream and other things like that, and their freezer wasn't working. Went up on the roof and found that the fan on the condensing unit, which is almost open, almost totally there, a little bit of roof on it, but it's not what you'd look at a home unit. Well, I did not have the fan. The fan was a special size, a special amperage. There was nothing I had on my truck. This was a Saturday night. There was no one to find this motor. I called a few of the suppliers that had someone on call. No one had this motor, so it was going to take a few days. What I did to cool it, and this is something that in an emergency you can do, I took a piece of PVC 3/4 inch pipe, drilled holes along the bottom, and this was the condensing coil was a slab coil. It wasn't round. It was about 2 feet by 18 inches, and it was about 4 inches thick. I took a hose. Most roof air conditioning systems always has a hose connection on the roof so you can clean things up. I took that hose, put a fitting onto the plastic pipe and a cap on the other end, and I turned it into a drip system. I used zip ties to strap it to the ends of the coil and set it right across the top. So I turned on just enough pressure to have drip, 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 drip coming in through all the holes, and it worked. And it worked for 3 days until I got back out there with a motor. So it's one of those things that you don't have to just use air when it's air cooled. You can use water cooled. Now it wasted a lot of water, but it's on a roof outside. It's no big deal. It's not going to hurt anything. But there's times you can do things to get a system running when you can't run it the normal way. This used to prevent low pressure as well. So I had to be very careful when I did this not to put a lot of water. I can't just have a hose pouring on it because it won't work properly. It will overget too much subcooling. So it had to go the right amount. But I was lucky, just a few drips every second out of each hole seemed to do it fine, and I watched it for almost an hour to make sure it continued. Head pressure control method, pressure regulating valves, condenser splitting, condenser air louvers, fan speed control, and cycling electric heat. It's not unusual for certain air conditioning systems and high dollar, very efficient systems that outdoor fan doesn't come on right away because you want it to build pressure faster. The longer you keep the fan off, it doesn't come on the minute the compressor comes on, because it'll build up that refrigerant a little bit faster. And then after a few seconds, the fan kicks on. But on the refrigeration system, that happens a lot. There's a temperature that controls whether the fan comes on or not. Head pressure operated louvers. Again, these are something that allows air in or diverts air from coming in, just to make sure the temperature works properly. Fan and electric heat head pressure control. You can turn the fan off and on during certain times when the pressure builds up. It puts a little bit stronger fan on. When it cools down, it lowers the fan or shuts it off for a second or two, or maybe up to a minute. They also have heat elements that goes into the receiver when the refrigerant is not enough pressure. It can build pressure by using heat as well. Suction line, liquid line heat exchangers brings liquid refrigerant into the suction lines, contact for heat transfer. It helps both the systems work better when they do that. They're very high tech, and a lot of companies just don't use them, but there's a few out there, mainly for refrigerant, that uses them. Commercial refrigeration subcoolers further reduces liquid line refrigerant temperature below saturated temperature, increases heat removal and capacity of the system, improves efficiency. They really do. This is all these companies work on now, is how much money they're going to save, either the business or the homeowner. So it's very important to be able to do it. So when they find a way, they do this. Primarily used in large, low-temperature commercial refrigeration systems. So you might have a commercial freezer at an ice cream company that is just a fortune to keep it at below zero all the time. This helps with that. It might only save them 5%, but 5% of $1 million a year in cooling costs is worth it. Commercial refrigeration subcooling system design. Definitely, this is almost a whole page in the books. It's good information. Take a look at it. Plate heat exchangers. These are mainly used for large industries. You can use them for water, refrigerant. You can use them for a lot of different things. These are the thin metal sheets that get welded together to create a surface. Sometimes they're not welded. Sometimes they just have O-rings and bolts that hold them together. Those are rebuildable, but they're very efficient in heat transfer, used in food and beverage production and pharmaceutical industries. They're very consistent temperatures. They don't fluctuate a lot because they don't use air. Some can be serviced and rebuilt. It's a big plus for those. You can see these plate heat exchangers. These have been taken apart and they're being cleaned, and then they'll put new O-rings to separate the outside and the inside of these items and put them back together and save thousands of dollars every time they do this. Heat recovery systems. These are great for domestic hot water. For example, you have a heat pump or an air conditioner that sends, instead of sending the heat from the compressor out the condensing coil by air, you actually put the refrigerant liquid line into this unit, or the vapor line into this unit. And this holds water, and there's a coil inside that will heat that water. And not always will heat it up to the temperature needed, so there's always electric backup. Series arranged heat recovery system. Congratulations, this is the last slide out of 63. It's a very large PowerPoint, as you probably noted by now, but this is the parallel arranged heat recovery system. Again, good pictures in the book.